Okay, so hello, my name is Jason, and our senior project team was proposing a new power converter design for the architecture or the power architecture in today's data centers. And our team consisted of me, Jason, Tristan Arellano, as well as Stan Wallace, and our advisor, Professor Badawi. So, our reasoning behind proposing this new design was basically that the current power architecture just can't handle the growing energy demands that are put on them as, society's needs for things like data transmission and storage increases. So, our goal was just to help improve the efficiency of this architecture today through a new power converter that focused on either, or that would be implemented in either the 48 to 12 volt category, 12 volt to point of loads, and 48 volt to point of loads. So during our first semester working on this project, we were separated into three different research teams here, where one was on 48 to 12, 12 volt to point of load, and 48 volt to point of load. And we would be doing market research on these different types of power converters, and we'd be running simulations on LT Spice, Simulink, wherever models were available, and we'd be comparing them. And essentially, we'd just be gaining experience with all these separate simulation softwares, as well as gaining knowledge about how to work with data sheets and using them to make our own designs. And at the end of the semester, we came together as a team to finalize a single design that would only focus on one of those categories. So, once again, 48 to 12, 12 volt to point of load, or 48 volt to point of load. So this was how the work was actually divided up among us three. So I was responsible for 12 volt to point of load, Tristan with 48 to point of load, and Stan with 48 to 12, as well as doing research on a converter topology called LLC, which you'll find more details about it in Stan's video. So here you could actually see what our second semester responsibilities were as well, and in the end, we decided to go with the 48 to 12 volt category as well as the LLC topology, and that's why we have LLC over here, LLC applications for every single one of us. And I'll go into more detail about why we chose that later, but just know right now that the second semester responsibilities include these because we decided on that specific topology and this specific category of converter to focus on. So here you can actually see the design specifications for the converter that we were working with and trying to build this semester, which we unfortunately didn't get to, but these were the parameters that we were working with when we were running simulations. So we were working with the LLC topology, the 48 volt to 12 volt category, which we decided on because the 48 volt to point of load just simply had no solutions or examples on the market, so we'd essentially be working with a blank slate. And the 12 volt to point of load already had a number of very strong solutions currently in the market. So we felt that the 48 to 12 volt category had the most room for improvement and innovation. We were also working with an output power of around 1 kilowatt, and we were also trying to decide between direct frequency control, hybrid hysteretic control, or phase shift modulation control as our control algorithm. And Stan will actually cover more of DFC and HHC in his video, as well as research behind the LLC and the 48 to 12 volt category. And Tristan will be covering more of phase shift modulation control, as well as the 48 volt to point of load in his video. And I will be covering more of the 12 volt to point of load, as well as transient simulations and how to work with the models for the HHC model that we were working with in Simplus. And that concludes the intro video for our senior project and what we achieved throughout the course of these 2 semesters.